Hello, everyone, and welcome to our presentation in Tracking the Problem. We are Team Monroe, and we are going to be discussing today all the issues related to problem tracking and bug solving related to our software testing, software development environment. We hope you enjoy. So, as I mentioned before, we are Team Monroe, and we're composed by four members. We are TC, Linky, myself, Alex, and David. Without further introduction, we're going to go ahead and begin talking about the problem.
Sometimes simply referred to as a bug, is a situation where the observed behavior of software or product is not the same as the expected. These problems are usually discovered by either the users or the software developers. Unfortunately, simply editing the code doesn't necessarily constitute fixing the problem, because there may be a misunderstanding or misinterpretation on how to use the application. Also, there may be external factors that are out of control of the programmers. One famous bug is the Millennium Bug, or Y2K, which was characterized by a combined short-sightedness of the computer professionals in the decades leading up to the year 2000. Basically, in many computer systems, 2 digits were used to show the date. But this was a practice that also predated computer systems. So, for example, the year 1998 was simply represented as 98. What they didn't anticipate was that there would be a problem once they went past the date 2000. But more common and familiar bugs to us as programmers and developers would be, for example, improper input validation, race conditions, information leak in in error messages, memory leaks, or even errors transmitting sensitive information. This leads us to the life cycle of the problem or the bug itself. Basically, from the first occurrence of the problem to its fix, the life cycle of a problem or the bug can be summarized in 5 steps. First, the user informs the vendor of the problem. So now we have a problem. The vendor then attempts to reproduce the problem. Once the problem is reproduced, the vendor isolates the circumstances causing the problem and then proceeds to make a fix locally. Once a fix is made, then it is delivered to the user. The life cycle, however, must be organized in a way that is managed appropriately. Managing this process calls for the ability to answer the following. 1. Which of the problems are currently open? An open problem indicates that there is probably some defect in the software that must be fixed. 2. Which are the most severe problems? Typically, the most severe problems are the first to get fixed. And then finally, did similar problems occur in the past? If there are similar problems, then there may be a solution on hand that only needs to be delivered. Of course, once a bug is identified, the entire process of delivering a fix is the vendor's responsibility. The vendor may, however, consult with the user in order to be able to replicate the error, and then thereafter the vendor will proceed to find a solution before delivering it to the user. This leads us to the problem report and the interaction between the user and the vendor or the developer. The problem report, also known as a change request, bug report, or a bug report, follows the basic principle of capturing all the relevant facts. The operative word here being relevant, because these are only the facts relevant to reproducing the problem from the developer's perspective. What to report? Well, bug reports need 3 basic pieces of information. Number 1, a description of the experienced behavior. Number 2, a description of what was expected. And then finally, a one-line summary. A poor bug report, for example, would be one that merely reads, "Your program just crashed. I just wanted to let you know." This report does not highlight the expected behavior, nor does it give a description of the experienced behavior. It does, however, have a one-line summary. An example of a good report would be one pictured here, which is a screen grab of Apple's bug reporting interface, which basically includes information such as a descriptive title of the feedback of the problem, the area in which the user is experiencing the problem, and then what type of feedback they're reporting, whether it's a comment or actually, a fix request. Also, it includes the build in which the bug occurred, and then steps to reproducing the problem. Also, the user can attach a system diagnostic file on here or images or video pertinent to the problem. Some some programs actually collect information for diagnostic purposes while they're executing. If the error occurs after a long series of events, it's often difficult for the user to retrace all their steps from the problem from the beginning of the program to where it failed. And therefore the program can also be set up to record important events in a log file, which can then be later forwarded to or examined by the vendor. The product release information. The second category of facts refers to the product as well as the environment in which the problem occurred. The product release is the version number or some unique identifier of the product that can be used by the developer to recreate a local copy of the program in the version as installed by the user's environment. Also, operating environments. The operating environment version information. This is the version information about the operating system. Since problems may occur because of interactions between third-party components, information about these is also necessary. System resources. Some problems occur only under limited resources, including information about the system's memory, disk space, and other hardware resources may be pertinent to the developer and being able to reproduce the problem. Looking on how a system's information impacts the failure can be helpful. For instance, if you are a tester, try to generalize. Does the problem occur under alternate releases too? Does it occur in the most recent version? Knowing the details about the product and its environment can be crucial if the problem indeed depends on specific product or environment features. In a study by Bettenberg et al., though the developers consider these facts secondary, hardware and some degree OS fields are rarely needed, as most of our bugs are usually found in all platforms. Food for thought. Facts on the product and the environment can easily be queried automatically as well. There are, for example, Apple has a talkback dialog that literally all you have to do is click a send to Apple and it sends a report for you. Finally, the problem history. Most developer teams keep track of the current problems in their system using a single problem list. This may be a document that they use to keep the list of all open or unresolved problems to date. Such a document is easy to set up and easy to maintain. However, associated problems include the following. Only one person at a time can work with the document. An exception, the document is in a version control system that allows parallel editing and later merging. Number 2, history of earlier or fixed problems is lost. An exception, the document is in a version control system and evolves together with the product. And then finally, it does not scale. You cannot track hundreds of problems or different issues in a simple text document. So the alternative to keeping a document is to use a problem database, which stores all problem reports. Problem databases are scalable up to a large number of developers and users, and the problems themselves entered into the database. And these can be used later on in order to be able to fix similar problems for this product or even future problems or future products. And so that is all that I have on tracking the problem. I'll now hand it over to my teammate, Linky. Thank you.
The expected behavior is made up of the difference between what the user thought would happen and how it has really performed or what happened. While purchasing a software, the client or the user may have expected that it would not have any error, but there is also a scenario that the user might be expecting an error in the software, but to their surprise, the error may turn out not to be the expected one, but a different one. The bugs or flaws contained in this report may be the reason that makes the software not to serve the client or not to execute its work, and hence requiring major changes. The report may also contain bugs or the difference that may create discomfort in the user's process of using the software in question and thus need improvement. The observed behavior entails a report on what the user knows about the specific software. The user must provide details of what indeed happened or took place. Usually, the user may basically record or report what happened to the software or what they saw, and this means that the report contains what the user observes. In the report, the user identifies the individual features that do not work or do not appear as they are supposed to be. The report may also identify errors that may not qualify as observed error. The managing problem file. When a client reports a bug in the software, there are several steps that the provider must take. The first step is that the moderator will establish the status of the bug to help the course of action to be taken, and when the status is unconfirmed, it means that the issue is not addressed and thus needs to be assigned to someone to begin addressing it. The second step is the checking of parameters, and this means establishing all the details and the features of the bug so that the assigned person may know how to address the issue. The third step is updating or resetting its parameter so it can be easy for the assigned people to address the problem. The fourth step is that the moderator will allocate an individual to address the issue or deal with the problem. And the last step is that the assignee will fix the identified problems, and once this is done, the changes may be updated in the product and making it ready for use. Problem database. The first step in effective management of a problem database is the classification of the bugs into the various categories to help the course of action on the report bugs. The database also needs to update report on the status of the bug to ensure that no bug is left, and there is a speedy approach to the problem to ensure that the customers get the serve in good time. In the case of an open source system database, they must ensure that it is easy for any person to submit a code or report a bug so that all the customers can be timely assistance. Also, the moderator must examine the code submitted into the system to protect the database from malicious actions. In the case of a closed system, they must ensure that it does not lock out anyone who may wish to report a bug, and this is by ensuring that it is possible to report bugs through feedback platforms and also the emails. When a bug reaches the Bugzilla database, it assumes an unconfirmed status, and this is to ensure that immediate action begins with addressing the problem. After a review, the status of the bug changes to new if it has not appeared in the system before, or it changed to assigned if there is an individual already working on the same to avoid the duplication of activities. The assigned individual addressed the bug by correcting all the flaws that appear and then change its status to resolved after he indicates the action taken on the problem to provide proof that the issue is addressed. The moderator then checks how the assignee has addressed the problem and check whether it is well solved. After establishing that all the required changes have been made on the product, the bug closes and this means that the problem is properly addressed. The problem severity. The severity of a bug implies the degree to which a bug affects software functionality. Severity is an indicator of quality of the software based on how the bugs affect its performance. The testing engineer establishes the severity of a bug by using the written test cases or how it performs. After testing the software and establishing its functionality, the engineer is able to assign the degree of severity. After the engineer has identified the severity of the problem, they can fix them, relies on the severity. Problem priority. Bug priority implies how fast the problem identified in the software requires a resolution, and it is also about grouping the problems in the order by which the assignees will work on them. Priority relates to fixing schedule, means from the most urgent to the least urgent. When a problem earns a high priority, it means that it needs early intervention, and when the priority is low, intervention may come later. The priority of a reported problem basis on the priority of a reported problem basis on the business and the marketing aspects means that when the problem has serious business consequences or interferes with the sales, it must be addressed as soon as possible to avoid an outage. Also, it is the responsibility of the product manager to set the priority of fixing the problem issues based on the marketing and the business aspect, as mentioned above. The problem identity. The bug problem identity is about the identification of the failure in regards to its type, and the types may include the process failure, the logic, faulty code, constraint, abstraction, real-time anomaly, accuracy, and some operator errors. The process failure means negligence or human error may lead to process failure and leading to malfunction. The logic implies errors in logic processing, and this may hinder the functionality of interrelated parts of a system. Faulty code implies the improperly written code that may lead to runtime problems and overflow, and this may provide useful channels for hackers. For constraint, some of the examples include the buffer overflow and the stray pointer, and thus affecting the language of the software and the data. The abstraction is a form of misinterpretation of algorithms and may lead to poor encapsulation of the information.
So the final thing we're going to be talking about related to this whole bug issue and how it what it encompasses and all the different things that it covers is going to be the notification part. What is a notification? It's pretty much the ability to generate any sort of alert to the developer or whoever the person is in charge of the situation. There's a couple of important things about a notification. If we want to have a good notification system, we need to have fast, accurate, very detailed and notifications, and we need to know the source. We need to know where it comes from. It is important to note that nowadays most of the things in our life they are related to notifications, to alerts. We know that we got an email because our phone shows a number next to the email app, or we know we got a text message or a message on Facebook, or somebody they posted a picture with us, pretty much because we get notifications about almost everything. We can apply this knowledge and all this common sense that we have developed with through our daily life to this sort of notification system that a bug, any company must have. When a bug is generated, the developer needs to get some sort of alert saying like, "Hey, this and this and that is happening." So the better the notification, the faster the developer is going to be able to understand the problem and actually act on it. Moving on to the actual company-based system of the life cycle of any bug within a company, we're going to be talking about a few of the different steps or stages that are most common within the different softwares that can be used for bug tracking, which are unconfirmed, new, assigned, resolved, verified, closed, and reopened. An unconfirmed problem could be anything from a bug being reported from a user to something a developer within the company suspects is a bug or has a bug, but it hasn't been confirmed. Nobody from a team or there has not been any deep investigation on the bug, so there's no actual knowledge that this bug is 100% true. Once the bug or the problem is confirmed, we call this a new problem, because we have already verified that there's actually something bad going on with the code. The bug has been reproduced, we know what's going on, and we open a ticket as a new problem so that we know that anyone from the team or anyone that remains related to the problem can now be assigned to this, and someone must complete it and develop a fix for this, or at least have some sort of resolution, which is something we're going to be talking about later on, the different types of resolutions that a problem can have. So once we have a new problem or a problem that we know that has been confirmed, we have to assign this problem to a team member, division within the company. The problem has to be assigned to someone. It might be the case that a problem is assigned to a team member, and then this team member feels that they know someone else from their team that can do the job better, or that they can pretty much do it faster or have a different approach, and they could delegate all the task to a different team member. So the assignment within a problem is pretty much giving the responsibility to someone within the company for the completion of the fix, for at least finding a resolution for the problem. We have been talking a lot about resolution, and we really haven't talked about the different types of resolution that we can have. There's plenty out there, and depending on which software you decide on using, there could be 20-25 different resolution types out there on the market, and depending of course on which software your company decides, and your company is going to decide on the software based on what the needs they have, what software is adapted better to whatever they're developing. But the most common ones are the ones displayed here in the screen, which are completed, fixed, invalid, rejected, unresolved, and one fix. A completed problem is something that whatever work was going to be done by the person who got assigned this task is done. So whatever happened, the person is not going to keep working on that, and he or she considers that the work on that bug, even if it was fixed, not fixed, whatever happened, is done. So we all know what a fixed bug is, but it's always good to remember that even though something can be completed, maybe it is not fixed. So a fixed problem is such problem that has a solution to whatever the bug that was reported or found is, and that it could be shipped into production. Even though we have a verification or validation process, when we have when we initially have a problem is unconfirmed, we need to do some sort of confirmation process to get a new problem. There could be a case whenever the bug is not able to be reproduced anymore, or it simply stopped working, or something apart from the actual development happened, and such bug is not valid anymore. There's no bug of that type occurring. It could also be the case that because of a bad practice within a team, a bug was duplicated and then somebody else fixed it, or maybe you try documenting a bug within the system, and then you want to break it down to smaller pieces, and then the initial ticket that you created is not valid anymore. You want to break it down into smaller pieces to have easier pieces to tackle and finish the problem. There's many things that could happen for a problem to be invalid, but those that I mentioned are the ones that I have seen myself most commonly on the market out there. So and we also have a rejected problem, which could be the case that maybe the developer that got assigned to this decided that he or she doesn't want to work on it anymore. There's also many cases where this could happen, but the there's no need to spend so much time on this rejected because it doesn't usually happen that much. If you get assigned something, you complete it, or the worst case scenario, it is invalid. But it's really strange when something is rejected. A non-resolved problem is whenever we finish the all the development cycle, and then maybe the developer didn't find a solution to the problem, and through this type of resolution, we encourage other team members or maybe other teams to try to work on the bug and try to see if someone else can auto assign that task to themselves or himself or herself or whatever, and try to find a solution to this. And finally, there's always the one fix, which is pretty much that the team has decided that there's the fixing of this bug is maybe not cost effective, or that the issue with the system is not needed anymore. Maybe a patch that's gonna be launched later on is gonna fix this, or maybe it's gonna get rid of the feature that has a bug or something like that. So there's no need to fix it. So with all this in mind, we can now go ahead and say that a resolved problem is one where the development team is done working, has made a decision. It could be that it is fixed. It could be that they don't want to work on it anymore. It could be that they don't think that it is worthy of their time or of the time of the company, that they have to put so many resources into that, and then the result is not going to be that valuable to a company. So just pretty much any problem that has a resolution already is considered a resolved problem. In any good company, or I want to say that in more and more companies every day, even the best coder gets reviewed. Even the number one coder needs someone else to look on their code and say, yeah, that what you did is
It's
correct.
10 o'clock.
Because it could be the case whenever the code that's going to be shipped, the maybe doesn't match the fix that we wanted to do, or maybe the developer didn't understand the actual bug fix that had to be done. So the quality assurance team has to come ahead and then try to break down your code and see if it actually works, see if it actually fixes whatever had to be fixed, and if the solution provided actually fixes the bug, and it could be launched or shipped to production.
So, once a problem has gone through all of the previously mentioned states and become verified, it can be delivered to the users. Once the problem solution has been delivered, the problem can be marked as closed. Now, after a problem is closed, it sometimes happens that the problem occurs again or it was not successfully fixed. In this instance, rather than assigning an entirely new problem, we just reopen the previously closed problem. Reopened problems must be reassigned to new team members. A very common thing in a lot of companies these days is a software change control board. SSCBs are in charge of overseeing a lot of the problem management process. They're typically made up out of developers, testers, configuration managers, and they pretty much oversee verification at each step of the problem lifecycle and the steps we just mentioned. SSCBs also tweak the problem management systems of whatever company they're at to meet their specific needs, such as problem-driven development. Now, when we say problem-driven development, we're talking about using the problem tracking system to actually guide the development process as well as the debugging process. And the way you do this is you enter requirements into the system in the same way that you would enter problems, and you go about assigning and distributing and completing them in the same way. So typically, the tasks will get organized hierarchically, and the managers can assign them out based on priority and appropriate employee skill set. So requirements that are vital get pushed to the front of the queue, just like bugs that desperately need to be fixed. And then some bugs that resources don't need to be allocated to, or it's not really worth fixing it, can be put on the back burner, just like some minor development features. Now, even with the best possible problem tracking system, it's important to manage all the clutter of problem reports that come in. Some companies as big as Microsoft get millions of problem reports a day, so it's important to be able to filter through all the mess. An easy way to do that is to make sure that duplicate problem reports of the same issue are grouped and not assigned as new problems to different employees. Unfortunately, this isn't always as easy as it sounds due to the high levels of ambiguity in user-generated problem reports. So one way around this is to simplify the options a user has in their problem report with some predetermined options so they can just select from lists and have diagnostic systems fill out their system informations to help reduce some of the noise that comes in through the problem reports. Additionally, problem report databases can get cluttered with old problems that just haven't had any solutions applied to them. So sometimes when problems are deemed not worthy of being worked on, they need to be marked obsolete so that they stop cluttering up the problem database. An easy way to give yourself a headache is to try to manage problem tracking over programs with many fixes and releases across multiple versions. And an easy way to do this is to incorporate a version control system into your problem tracking system. So a VCS keeps a main branch of the program software as well as trunks with the fixes and updates for each version. And each source base, when it gets shipped, gets marked with a certain tag so that when a user submits their problem report, the problem environment can be accurately recreated by using the source tags to recreate the appropriate program version. This allows developers to work on fixes for a current version without having to worry too much about changing the plans for future developments in process. And of course, a lot of this mess can be avoided altogether with simple, good test cases. Many bugs can be caught on the developer end before any product is shipped to the users for them to send problem reports. And a test case which exposes a known previous problem can be kept to be iterated in subsequent development versions, and you can make sure that the new version doesn't have an old problem. Unfortunately, however, test cases will never catch everything, and problem reports will always be necessary. But there are a few things that can be included in problem reports to make them really effective. And the first thing is obviously the problem history, which is when the problem started occurring, how many times it's occurred, that sort of thing. And then, of course, you need your system's diagnostic information to know the hardware and software running. Thankfully, a lot of that can be auto-generated by diagnostic systems for problem reports, though, if companies are wise enough to include software in their reporting system. Next, the users should say what they expected the program to do and then what it actually did to ensure that there are no misunderstandings between what the program's actual intended purpose is and what the user just expected it to do. So everything I just listed is pretty much critical in any problem report, but some things that can just help out a problem report is having it be structured well and having your problem be reproducible from the steps that you describe. So you should be able to follow your steps exactly to recreate the problem you're reporting. And a summary can really help weed out a lot of the duplicate problems, and generally just keeping things simple and concise can really help manage the clutter of problem reports. So there are a whole bunch of bug tracking systems that are available. We talked about Bugzilla pretty extensively earlier, and PHP Bug Tracker is a good option for maybe some smaller developers. It's really lightweight and easy to take care of and set up. And Issue Tracker is pretty similar to PHP, but it is an extreme emphasis on ease of use, accessibility, so even DIY startup developers can manage it pretty easily without any third-party sourcing. Track, which we also showed a bit of earlier, is open source, which is really great, but One of the most useful features is that it integrates very well with version control systems. SourceForge can automate a lot of the process. It's a bit more heavy duty, and it even has a bunch of auxiliary functions like forums and archives, but its developers do offer commercialized support. So if that's not your thing, a better option is GForge, which is pretty similar, but the developers don't host any programs. So that's it for Team Monroe's presentation on tracking the problem. We apologize that we didn't get to have the full length of our discussion in the class. Hope that everyone stays safe during the hurricane, and if you have any questions, we would love to talk about some of the stuff in class with you.